Australian astronomers have led 2 decades worth of research into finding baryon particles, the universe's missing matter. They think they've cracked it, and Dr. Brad Tucker and I discuss on this Talkin Science Story of the Week.
Across Apple Podcasts, Spotify, Google Podcasts and YouTube, this is Talking Science with Dr. Brad Tucker and Matt Miller.
Australian astronomers using the Square Kilometre Array Pathfinder have spent the better part of 2 decades looking for the universe's missing matter. Where'd the universe put it, and how did it tell us to go look for it?
Yeah, so one of the things when we measure or add up how much matter there is in space. Now, when we're saying matter, we're not talking about dark matter. We're talking about normal matter, atoms and protons and that sort of thing. We can kind of weigh the universe. We can figure out how much it is, how much is there, and there appears to be some missing. That's what we call the missing baryon problem. A lot of things have been done to solve this because it requires a different way of kind of probing and measuring and weighing the universe. And so using what's called fast radio bursts, these are bursts of light that emit radio signals. And we've talked a lot about this before. They've been able to travel and trace how those radio signals are going through space. And they've been able to see that it appears that in some cases, it's going through baryons by the way it affects the way the travel of light and kind of gives a sign or a way of seeing this missing matter because it's missing and we haven't been able to see it before.
What I love about this is that the astronomers have been researching this, as I say, for 2 decades almost, since the mid-90s. And those fast radio bursts came in about 2007, but weren't quite fully understood. So it's taken a little while to process all the data and work out exactly what is going on.
Yeah, when the first one was discovered by Duncan Lorimer, it was kind of, what is this? And then a few years later, I started finding more and it became a real thing. And I remember when fast radio bursts were first just coming on, one of the first mentions was that you could potentially do something like this. You could potentially trace what's in between you and the fast radio burst, because these bursts are milliseconds long, and the way they fade as a function or as a rate of frequency, if something affects that slope or that change, you can measure what's in between you and the source. So it's kind of like light going through a prism, or if you have a glass of water and sunlight goes in, it's refraction, and it's essentially a similar process here. And so by using the way the radio light traveled through different parts of the universe, so these fast radio bursts happen all over, you can trace different pathways through the universe and therefore pathways through different stuff. And what they found is that in some cases there clearly was an effect of traveling through something and causing this kind of light bending or refraction and being able to see this missing matter. So really hopeful that it turns out to be exactly correct, because it's a really big important thing in knowing exactly how much stuff is there and being able to see how much stuff is there.
And we've talked about on Talking Science before about how we need these large telescopes. The night sky is huge, so we need large telescopes, and unfortunately, the bigger you get, the harder it is to manufacture. So we're moving along to Square Kilometre Array is one project that's working like that. The Pathfinder project in the Midwest of Western Australia is an array of 36 radio telescopes, which provides about the coverage of, or the same coverage as a 4,000 square metre dish. Now, given the scales, I think it's a lot easier to produce 36 little telescopes instead of one big 4,000 square meter one.
That's exactly right. You don't know where these bursts are going to come, so you just have to have a huge amount of area and looking all over. It's like looking at a meteor shower on, at home. You want to have a nice, wide, clear view so you can see as much of the sky as possible. In this case, you just need a big telescope or a wide telescope. And it's, as you said, sometimes too hard to build a single one. And they're looking at an area, as you said, it's about 60 times the full moon, which is a pretty big chunk of area to be searching in every single image just to see these fast radio bursts. And it's not like you have any prediction where they're going to happen. You just have to keep looking and looking and looking and get lucky and wait for them to appear or explode or happen and you to be pointing at the right place at the right time for something that literally only lasts a millisecond. So, there's a lot of, it's not just luck, but making sure you devise an experiment so you actually find something.
And of course, having said that it's Australian astronomers using Australian telescopes, we should acknowledge the work of the Very Large Telescope in Chile, which has been, we've talked about its work previously. So it's a very busy little big telescope over there in South America that's also measuring the distance between the Earth and the galaxies where these fast radio bursts are coming from. So it's basically picking up what ASCAP is finding and analysing it and measuring it.
Yeah, that's exactly right. Nothing is done solely, and these are also all projects with tens of people, upwards of sometimes 100 from all over the world. So it is a very international collaboration, but it's always nice to see the instruments and tools of Australia being at the forefront of cutting edge science.
And just lastly, Brad, on this one, making this discovery doesn't mean that we're going to be learning all there is to know about the universe. There's still plenty of stuff out there that we don't know about.
Yeah, there's a laundry list of stuff we don't know about. And again, this is, firstly has to be confirmed. You want an independent way of measuring it. You want to obviously reproducibility is another aspect of science. So being able to go out and see it again and making sure, your hypothesis is correct of what you see. So, it's kind of this finding that right balance between making success in discoveries and also understanding what those discoveries mean. So there's still a lot more to go.
Aussie astronomers leading the way in fundamental research into our universe. Absolutely fantastic. Well, don't forget to follow Brad on social media. On Facebook, he's Dr. Brad Tucker. On Twitter, he's btucker22. Trekzone is all over social media as well. Facebook, Instagram, Twitter, Tumblr, and YouTube. Like, follow, and subscribe to us. If you're watching us on YouTube, leave a comment. What did you think of this Aussie research into baryon particles? If you're on podcasts, well, hopefully you have subscribed to us and left us a review, and you'll get fresh episodes direct to your mobile device whenever you want to listen to us. I'm Matt Miller. This has been a Talking Science Story of the Week. Thanks so much for your company.